All right, today is common factoring and difference of squares. To start off, our starter says, what's the greatest common factor for 12 and 16? Well, 12 and 16, I can list my factors if that helps. My factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And of 16, I can list those factors, 1 and 16, 2 and 8, 4 and 4. And if I'm looking for my greatest common factor, the largest number that divides into both of them would be 4. Greatest common factor of 27 and 36. You guys try that one on your own. Hopefully you came up with the answer of 9. So what is a factor? Today we're going to talk a little bit about finding factors. And just by definition, a factor is a number you can multiply together to get another number. You can write that out. A number you multiply together to get another number. So when we're looking at common factors, such as this example here of 9x squared minus 6x, the first thing you do is you look at your coefficients, or the numbers in front of your variables, and you look for a common factor there. The greatest common factor of 9 and 6 happens to be 3. And then after you do that, you look at your variables. We have x squared and x, and we look for our greatest common factor there, which is x. And now the greatest common factor ends up being 3x. That just means we're taking each term and we're dividing 3x by each term. So 9x squared divided by 3x ends up with 3x. And we have a subtraction symbol, and then 6x divided by 3x is just 2. Now remember, if we're going to simplify here in this next part, simplify means get rid of parentheses. To simplify, we just distribute back. So we have 3x times 3x, and don't forget to distribute to your next term. So minus 3x times 2, which gives us 9x squared minus 6x. And now here we are, back to what we started. So finding our greatest common factor and writing it in factored form and expanding it, or writing in expanded form, are inverses of each other. They're different forms of each other for the same expression. So now at this point we can say we notice that factored form and expanded form are the same thing. So we can factored form and distributing or expanded form. They're opposites of each other, or are inverses. They still are the same expression, just another way to write them. So that means we can always check our factorized answers by distributing the terms back. So what a nifty way to always check our work. All right, so let's try factoring some here. We'll factorize the following, and we can check our work by distributing it back. So greatest common factor of 2x and 6 is 2. So if I factor out a 2 of each term, that means I'm dividing 2 from each term. I would be left with x plus 3. And I can check my work by distributing it back. So 2 times x plus 2 times 3 gives us 2x plus 6. Yay! Next one, 10x plus 15y. Greatest common factor of our coefficients here is 5. So I factor out a 5. I have 2x plus 3y. Notice that my variables are not the same, so I cannot pull out a greatest common factor of the variables. So distribute back, I have 5 times 2x plus 5 times 3y, which gives us 10x plus 15y. Go on to the next one here. Greatest common factor of our coefficients, there aren't any, 1 I guess we would say, but we have both the same variable of m, so we can factor out an m, so we're left with 2n plus m divided by m doesn't disappear, it's a 1. So now when we distribute back, we have 2mn plus m. All right, a couple more here. Oh, now we have a negative in both terms. Well, I can pull out then a negative 4. Oops, it said negative 4, but I wrote something else. So when you pull out a negative 4, it means I'm taking out a negative 4 of each term here. I'd be left with a plus 2. And here's just where you have to be careful and double check your signs and negative signs. If we distribute back in, we have negative 4a minus 4 times 2 equals negative 4a minus 8. Next one here, 8m squared n, 6mn squared plus 10mn. We first look at our coefficients and realize that the greatest common factor there is 2. Then we pull out our variables, m and n. Those are the largest that we can pull out. And it always helps to write out what your greatest common factor is in the denominator so we don't miss any terms. When I divide this out, here I have just 4. M squared divided by m leaves me with just m, and my n's are gone. Plus 6 divided by 2 is 3. Our m's cancel out, and we're left with 1 n on top. Plus 5, m's cancel out, n's cancel out, and there we are. You can double check by distributing back. We have 8m squared n plus 6mn squared plus 10mn. All right, here's a challenge one. These can get ugly. Let's look first at our coefficients. 12, 16, and 8. Largest, greatest common factor would be 4. We look at our variables. We have a to the third, a squared, and just a. So we take out an a. And we look at b, b to the fourth, b to the third, and just b. Only a b. C to the seventh, c to the third, and c squared. C squared is the smallest one. We can pull that one out. Now I will divide each term by 4ab c squared, 4ab c squared, 4ab c squared. Now be careful here. Take it one step at a time. 12 divided by 4 is 3. A to the third and a on bottom. I have more on top. How many more? 2 more. B to the fourth and b on bottom. B to the third. C to the seventh and c squared. I have 5 more on the top. Plus, we have 4a b squared c minus 2. Our a's cancel, b's cancel, and c's cancel. There you are. Here's another way we can factor. It's called difference of squares. It's when we multiply binomials that are conjugates of each other, we end up with another binomial. So for example, that's a whole lot of math vocabulary here. Let's look at this example where we have x minus 3 times x plus 3. And we've done this before with foiling. So let's FOIL or double distribute by multiplying each term. So we have x times x, which gives us x squared, and x times 3, which gives us 3x. Negative 3 times x, which gives us negative 3x, and negative 3 times 3, which gives us minus 9. Now here, if we notice, these two terms in the middle will disappear. When those disappear, we're left with just x squared minus 9. Now maybe you can take a guess why it's called difference of squares. Well, difference comes from the math terminology of being subtraction. Your difference is the subtraction symbol here. And squares, you guessed it, each of these terms are perfect squares. So we can always start with our difference of squares and move backwards or find the inverse by writing it in factored form. Now remember, this is our expanded form, and here is our factored form. So let's try it. Here we go. Whenever we have a expanded form and we notice that we have a subtraction here, that's our difference, and both terms are perfect squares, t squared being a perfect square and 49 being a perfect square, we could write it out in factored form like this. The first term, the square root of t, is just t. Next two terms is plus minus, and 7, 7. Just as before, if we wanted to check our work, we could expand back out or double distribute. So here, multiply your first terms, we get t times t, which is t squared. Next term, minus 7t. Middle term, plus 7t. And last term, minus 49. So we end up with t squared minus 49. All right, they're not always easy to spot. For example, if we look here at y squared, 1 is a perfect square, so we could do the same thing here. We could write this in factored form as y plus 1 and y minus 1. If we wanted to write out a general formula, we could say that a squared minus b squared equals a plus b times a minus b. Let's try using that formula here. We just have to identify what a and b are. So we have our subtraction symbol, so we know that it's going to be a difference of squares. Well, if this first term is a squared, then the square root of a, or a, must just be 3. If this next term here is b squared, well then the square root of 16z squared is 4z. Once I identify a and b, I can put it into my formula. A is 3 plus minus, and 4z, and we're done. These ones you're trying on your own, I'll go ahead and go through the solutions, but you can press pause now and try these ones on your own. Maybe you identified a to be 2t because you took the square root of it, and b to be 7 because you took the square root of it. Then you have 2t plus 7 and 2t minus 7. Here we can do the same thing. Take the square root of that. We get a to be 4a and b to be 5. So we have 4a plus 5 and 4a minus 5. Last one. Take the square root of both of them. We get a to be 6 and b to be 10x. So then we are left with 6 minus 10x and 6 plus 10x. Oh, did you notice something? I switched these plus and minus. Doesn't matter. No, not really. So it doesn't matter which one you write first.